السلام عليكم. أهلا وسهلا بالجميع and welcome everyone. بإذن الله تعالى اليوم سوف يتم تقديم محاضرة من سلسلة محاضرات عملية تتطرق للمجال العملي بشكل خاص. محور المحاضرة الأساسي يتكلم عن النتورك security and overall infrastructure security، مقدمة بالمهندس صفوان أكرم. طبعا مهندس صفوان غني عن التعريف ما شاء الله. He's a cybersecurity expert with more than 6 years of experience in the field of network security and cybersecurity in general, with a multiple of professional certificates such as the CCIE routing switching, CISA and CISM, and many more ما شاء الله. ما نطول عليكم، مهندس صفوان, you have the control. Thank you.
السلام عليكم، حياكم الله جميعا، يعطيك العافية فادية. Welcome everyone. I would like to first thank SIAG community, its leaders and members for providing this opportunity to the audience, to the cybersecurity field students, fresh grads, which are the main audience for this lecture, and for anyone interested in cybersecurity in general. Okay, again, my name is Safwan Akram. I'm an engineer currently working for STC Solutions as a cybersecurity expert. I'll begin just by going for an overview of what I'm going to be talking about today. I'll shed some light into my own background and experience as it might appeal to some of the audience. And then I'll begin with some network 101. Before we dive into the security part of networks, we first have to understand a few things about networks to move forward. And then after that, I'll begin with the security part with some foundation and base knowledge, let's say in information security in general, before we go into the security risks and some of the controls and mechanisms that we use to mitigate those risks. After the lecture, we'll have a mini lab for you to visualize what is a network, how we secure those networks through different controls, and then we'll give the floor to you for any questions that you may have. All right, so I started my academic career at KFUPM as an electrical engineering student. Some might wonder how come an electrical engineering field is now becoming in the IT and the cybersecurity field. And I have 3 reasons for that. And those are the reasons why I picked electrical engineering as a degree in the beginning. The first one was the engineer name. So I wanted to have to be called an engineer after I finished my studies. The second one is my interests in computers. Since I was young, I always had an interest into gadgets, computers, anything that had any relation with technology. And after a lot of research during the first year, while I was deciding my major, there were multiple options for me: computer engineering, computer science, software engineering. And I saw after research that the job market demands electrical engineers more than the other degrees. So that's why I chose electrical engineering as a field to study. And among all of the courses as part of the electrical engineering curriculum, I only took one course that had a direct relation to IT, which was a telecommunication 101 course. It spoke about the OSI model, the TCP/IP model, and so on. However, that course alone ignited my spark and my interest in the IT field, in the network field in specific. So in my senior year at KFUPM, I was sponsored by Saudi Aramco as part of their college continuation program. And immediately after graduation, I worked under the IT admin area in Saudi Aramco as a network engineer. And I was lucky enough to be part of an amazing group which enriched my experience as a network engineer for about 4 years That's where I got most of my expertise in the routing and switching field, working on so many areas, wireless networks, MPLS, so many different solutions and platforms. And from that point on, I started having a special interest in cybersecurity. So I took on an assignment as a risk assessor as part of the risk management group, where we performed multiple risk assessments on infrastructures, on solutions as part of the organization portfolio. And just recently, less than a year ago, I moved to Solutions by CC as a cybersecurity expert. And below are some of the certifications that I achieved during my career. I'm a huge advocate of certifications, of training, of education in general, which is why I'm giving this lecture. And I highly encourage all of you as professionals, even as students, that you reward your experience, you reward your knowledge with certifications. It's very valuable to organizations and businesses. They look highly of persons with such certifications. And it also gives you a sense of self-satisfaction. Okay, just hold on. I just want to make sure that my voice is being heard and it's loud and clear. Okay. All right, so to move on, I'll be giving an introduction to networks and to emphasize the importance of having a strong network background for any cybersecurity specialty, as all of the cybersecurity controls or the cybersecurity field in general has to do with the networks at some point or another. Sometimes it's a bit far away if you're talking about, for example, application security, but at the end of the day, all of the application traffic, all of the packets are going to traverse the network. And all of these packets are network packets. They have certain protocols that are governed by the network. So that's why I'm going to shed some lights into some network concepts. It might be basic, but please bear with me. So what is a network? What is the first thing that comes to your mind when you hear the word network? A network is simply a communication between two or more devices, nodes, applications, you name it. Now, this communication does not only apply to certain protocols. It has so many protocols. However, in today's world, most of the communication is done through the IP protocol, the Internet protocol. And that's why we're going to focus on that protocol as the main protocol for our network communication. There are other protocols beside IP that some devices use for communication, but that's maybe less than 1% of the communication overall. So a network is two endpoints, two nodes that are communicating over the network using the IP protocol. And to understand how the traffic flows in a network, I'm sure that many of you are already familiar with this TCP/IP model, or the equivalent of the OSI model, which has more layers, which was simplified in this model. So this model has about 4 layers. Now, any communication in the network will traverse all of these layers. Okay, it's either going to go from top down or bottom up. So if you're sending, for example, an email from your phone, in that case, you're starting from the application layer. So you're actually sending an email using an application, using a protocol like SMTP, Simple Mail Time Protocol, and then you're traversing the network using those layers, the other layers, which is the transport, which handles basically the connection. We have 2 types of transport protocols. We have the TCP and the UDP. And we know that the TCP is used for connection-oriented communications, which means it's reliable. So if I send a packet using TCP, the receiver of that packet needs to send me some kind of acknowledgement so that I know the packet was received and it was received in the correct order. If not, there will be a TCP retransmission packet which asks the sender to send the packet again. So this ensures that, for example, if you send a file across a communication or a network, that the file at the end or at the receiver end will be the same file intact as the sender has sent it. And on the other hand, we have the UDP, which is a connectionless protocol. UDP is a best effort protocol that is mostly used for voice and video applications. UDP does not require an acknowledgement back from the receiver. So once I send the UDP packet, for example, I send a voice note across to the receiver, I don't really require that the receiver sends me an acknowledgement back. So if some of the packets along the network or the communication path gets dropped, it will not be retransmitted again. And we will just have to accept that risk. So UDP is only used for applications that can tolerate loss in packets, like video applications, like voice applications. If you miss a few packets or pixels, let's say from a video, you will not really notice anything with your bare eyes. So UDP is mostly used for such applications because it does not have an overhead on the network. It's just one packet going through, whereas the TCP is considered as an overhead a little bit because it's a three-way handshake. You first send a SYN packet, and you expect a SYN-ACK as an acknowledgement. And then again, as a sender, you send an acknowledgement to the receiver, telling the receiver that you received their acknowledgement. And this three-way handshake ensures that the communication line is intact between the two ends. Now, going down a little bit into the third layer, which is the internet layer. This is where we have the IP protocol. We have version 4, we have version 6, and we have some other protocols on this layer like ICMP, which is used for reachability. For example, if you ping a device, you're using the ICMP protocol. ARP is also a protocol on this layer. It's used for resolving IP addresses to MAC addresses. And the MAC addresses are actually used on the link layer, which is the Ethernet in this case, is the mostly used protocol on this layer. This protocol uses MAC addresses. So each endpoint, whether it's a phone, it's a laptop, it's a server, it has a MAC address on its network interface. And that MAC address has to be unique. It's a 48-bit MAC address. And that uniqueness gives it the chance to communicate over the layer 2 domain. When we're talking about a layer 2 domain, it's a domain where devices can communicate without having to have IP addresses. So if you connect two machines or two laptops, let's say, to a switch, a layer 2 switch, they can communicate through the Ethernet protocol. Now, why I'm mentioning this model is because of the importance of the understanding of any traffic flow. If you're analyzing, for example, an incident log, and you're seeing source and destination IP addresses, you're seeing source and destination TCP ports or UDP ports, you need to understand what each of these parameters mean for example, a SOC analyst. Or if you are a network security administrator, you definitely have to understand all of these layers in depth in order to troubleshoot, for example, connectivity issues, security policies issues, any issues that are on the network level. Some way or another, they will have to do with one of these layers. It could be an issue on the application, sometimes on the transport, and at other times, it has to do with the IP protocol. Mainly, we're talking about routing. And we also have some issues that come up on the link layer, which is the Ethernet, like having a broadcast flood or other things. And why this is important to network security? Because network security makes sure that all of these layers are protected against threats and attacks. All of the attacks will target one of these layers. Now, the majority of attacks in today's world are on the application layer. So the attackers, they have an attack vector on the application most of the time, because this is where most of the vulnerabilities are, on the application layer. However, there are also many critical and high vulnerabilities and threat cases on the other layers as well. So for example, on the link layer, you have threats or attacks similar to a broadcast storm, ARP poisoning. You can do so many attacks on the layer 2 domain. You can sniff traffic. If you connect, for example, your machine to the layer 2 switch, you can sniff the traffic using the broadcast. You can also spoof MAC addresses. So in order to protect or mitigate these risks, these security risks, we need to understand first how the network first works in these layers and on these protocols in order to be able to protect it. All right, so now I'll be talking a little bit about some of the foundations of network security and cybersecurity in general, in order to have a clear understanding of why we're having certain network security controls in specific. And this applies not only to network security, it applies to security in general, whether we're securing an application, whether you're securing an endpoint, a server, it applies to any information security field. So we'll talk about the network zones. Now, for the network zones, we have the basic form of protection of any, let's say, organization or business is through a perimeter firewall. It's a device that sits at the border of a network. That network is usually a trusted network. So we have two zones. I have a trusted zone, which is, for example, a company owned zone, which has its servers, its resources in terms of data and so on. Or if you are at home, your home network with its laptops, phones, and machines are part of that trusted network. And then you have the firewall in the middle as a perimeter control, separating you from the outside zone, which is usually an untrusted zone. Most of the scenarios could be another company, a third-party connectivity, or anything that you don't have control over, anything that you don't manage, you would consider to be untrusted. And this is the basic form of protection, is to have these two zones. And in any network design or architecture, this is the first thing that you would think of. And this is a very old model, but it's still used because of its effectiveness, but it's not the only one. And we'll talk about that later. However, now the point that I would like to highlight here is the importance of directions in networks in general and in network security as well. What I mean by direction is that if the traffic is originating or being initiated from the inside zone to the outside, it will be treated differently as if it came from the outside to the inside zone. And this is how we actually configure the firewalls in general. We have multiple zones, and we actually restrict based on the zones. So for example, let's say that this trusted zone is our home routers network, and we're connected to the internet through the firewall. Now, ideally, for a home network, you don't expect that anyone from the internet will try to reach you or initiate something to you, because you're not hosting an application or a service from your home, usually. As a home user, you are usually a consumer, meaning you from your home, you're trying to browse the internet. So you are initiating traffic, for example, to CNN.com. You are trying to view a video. So you are initiating that request to the internet. And the firewall is built that way. So by default, it will deny or block any connection coming from the internet or initiated from the internet to the inside zone or to your home in this example. And it will allow any communication to go from the inside out. because this is a trusted zone. So we trust anything that's coming out of the firewall to the internet. Now, this is in a very basic, small business or home setup. However, this kind of protection does not really apply or is not good enough to protect when it comes to medium or large organizations or companies. So we move on to the next design or architecture, which is an architecture that has 3 zones. The 2 zones from earlier, which is the inside zone and the outside zone, it will act as normal. However, for a business, usually you're serving some kind of, let's say, an application or a service over the internet. So you have some publicly facing servers, let's say a web server. So you're hosting your own domain on that server. Now, this web server will be accessed from the internet. So in this case, the firewall will allow, and it will be configured to allow the communication from the outside only to those applications or services in this zone, which is called the DMZ zone, the demilitarized zone. This zone is protected by the firewall, and it also protects the inside zone. And this is the main difference here. Why do we have a 3rd zone? It's not only to protect the DMZ and leave the inside, or the other way. It's actually to reduce the attack surface, such that if there is a breach on any of the publicly facing servers, we are limiting the scope for the attacker to only this zone, which ideally this zone will not hold any sensitive or confidential information to the company. This zone will usually have web servers, it will have public DNS servers, it will only have devices that, if were breached, will not disclose any confidential information. And these devices, when it tries to access the service, it will initiate another connection. For example, you are accessing the web server from the internet, you will go to the web server on the DMZ zone, and the web server then will initiate a connection to the inside zone, which will have your application, your database, and all of your resources that are considered confidential or it has sensitive information. So that way, we are just limiting the scope for the attacker. It's not a full protection. We always expect that there will be a breach. However, we are just reducing the attack surface here. All right. So moving on, before we dive into some of the network-related attacks, I'll just give an overview and a highlight about some of the concepts in the cybersecurity that are very, very important to understand. Now, there is something called the Cybersecurity Triad, or some would call them the cybersecurity pillars. These 3 pillars, and they are not in any order, are very important to understand, because any security control that is implemented will, in one way or another, enforce one of those pillars. So we have confidentiality. What does it mean? So we have a data. We have, for example, a file that contains a list of passwords for a specific user. This data is now considered as confidential for that user. So only that user should be able to access that data and view that data. So as a security concept, this data needs to be hidden or only be accessed by the authorized individual. So to enforce confidentiality of data, we have multiple means or mechanisms to enforce such a pillar. One of them is the encryption. So if you are sending, for example, this file across a network, whether it's the internet or another network, and you want this file to be confidential all the way, you need to encrypt that file. Or if that file is somehow protected by software, and you only need the user for that file to access. So you need some kind of authentication using a password, for example. Just like if you're accessing your bank account, you will actually use these two mechanisms or controls. So if you're going to your bank website, you will use HTTPS protocol to have a secure channel to the website so that the traffic traversing the internet is always encrypted. So even if someone sniffs it, they will not be able to see the traffic or see the payload. And you will have to authenticate with the bank with your username and password. And now with two-factor authentication using the one-time password on your phone to be able to access your data on the bank website. So those controls are enforcing the confidentiality. And that's one of the pillars. The other one is integrity. What integrity entails is that data, when it is being traversed through the network or the communication path, it doesn't get altered or changed or destroyed during that communication. So if I send a file that has only one word, that file, when it reaches the other end to the receiver, it should only contain that word and that word identically. If something changed on that file throughout the communication, this breaks the integrity of the data. So to ensure that we have integrity in our data and in our communication lines, we use multiple controls. And some of these controls include encryption. So most of the encryption protocols will ensure the integrity of data as well as the confidentiality. They come hand in hand. To ensure, for example, the integrity of a file, you could do a hash on that file. And the hashing algorithm is a one-to-one function, is a one-way function to generate a string that if you bring the same file and apply the same algorithm, it will generate the same hash. And if you compare the hashes and they are the same, then that file has not been changed or altered. So that's one way to validate the integrity of a file. Another method is doing backups. You can do a backup, for example, to an operating system data. And then if you want to compare if that file system has not been changed, you can go to the backups version control. So it's not necessarily always a technical control. It can also be an administrative one. Now we come to the third pillar of the cybersecurity triad, which is the availability. Now this pillar is very important. And in many cases, it overlaps with an operational requirement. And in some cases, it even conflicts with operational requirements. It depends. What availability means is that the information or the data or the service that the company or the organization is providing needs to be available when it's supposed to be available. So, for example, we expect that the government interface, like the Upshare website, to be available 24/7 all year long. So imagine if that website was brought down due to a security incident or an operational failure. That will definitely cause a customer or a user impact, which the cybersecurity also addresses using the availability pillar. So it tries to ensure that the data or the information or the service is available through multiple ways or means. One of them is the redundancy. When you're thinking of redundancy, you're talking about the service redundancy, for example. So you need to ensure that if you're providing a web service, that the end-to-end service is redundant. Or in other words, you don't have a single point of failure. So you have a cluster of servers, you have two firewalls, you have multiple routers, switches, and so on. So that you can tolerate any failure that happens, whether it's a software or hardware failure. Another thing that enforces availability is something called disaster recovery. And it's a concept that basically establishes a backup site Okay, it's usually in a different geographical area where you host your data or your service, such that if the main site were to go down for whatever reason, whether it's a natural reason or a security breach, you still have a disaster recovery site where you can initiate all of your services from there. All right, now I will talk about two approaches into cybersecurity and the evolution that happened to the approach when it comes to cybersecurity. So we talked about the perimeter firewall or the boundary firewall. And that used to be the main and most important control for any cybersecurity, let's say, strategy. So that firewall was denying what is not supposed to come into your inside network, and it was controlling that data. However, that simple perimeter firewall is no longer sufficient to secure your data. It's not sufficient to give you the assurance that you will not be breached. Now, the perimeter firewall can be configured in two ways. It can be on a whitelisting configuration or a blacklisting. Whitelisting is you deny by default all the communication and you only allow the applications that are intended or the applications that you are running, and you expect someone, for example, from the internet to access those applications. For example, if you're only hosting a web service, a secure one, so you will only open, for example, policies on port 443, which is the HTTPS port, from the internet to your DMZ. The other approach, which is not a preferred approach, which is the blacklisting. So you are implicitly allowing everything, but you are denying certain things. And this is not a good practice, of course, because you should be denying everything by default and only allowing what you need. So communication is by default going to be blocked, and you only allow and permit what you need as a company or as an organization. Now, this approach is still being used. It's one of the controls that we have, and it's an effective one. However, not against all the attack vectors that we have. They have become very sophisticated, and it requires so many controls to be enforced in multiple layers and levels across the network, the application, the people, the processes, the organization in general needs to adapt to a strategy so that we can mitigate the majority, let's say, of attacks. Because at the end of the day, there is no control or there is no number of control that can mitigate all the attacks, because there will always be a loophole, there will always be a vulnerability that will be disclosed and you will be breached. However, you will do the best of your intention to secure your network, your applications, such that you avoid, let's say, the 95% of attacks that are going to come your way. So we'll talk about the defense in depth, which is an approach that enforces cybersecurity in multiple layers. And it does not only have to do with technical controls like the firewall. So we'll start with some of the administrative controls that organizations are now following as a mandate and as a best practice as well. So as a cybersecurity strategies, organizations are encouraged to have policies. For example, to have a end user agreement policy, to have a password reset policy. So after a certain period of time, like 6 months or a year, all of the users need to reset their passwords. For example, password lockout policies, so that if there is a number of failed attempts, let's say 5 or more, then that user account will be locked for further investigation. These are policies, and they are very important because they drive the cybersecurity controls after, whether it's technical controls or other control. And usually these policies are enforced by a governance entity in the organization. And now this has become widespread in government and private sector organizations. They are establishing a GRC function, which is a governance, risk, and compliance function, to establish a risk management, to establish a cybersecurity strategy in general. We also have procedures. Procedures are guidelines for example, operations to perform something, or they are guidelines, for example, if you are making a change on a network device, or you're making a change on an application, you need to go, for example, through a change management process where you document that change using this procedure, and you go through some sort of an approval cycle following that procedure. So that process is going to be governed under a procedure called, for example, change management procedure. The third control is awareness. And this is very, very important. And this is one of those controls. It's an awareness lecture to spread awareness and also to shed some light on some of the specific network security controls. So by spreading awareness, you are hardening the weakest link in the chain, which is the human factor. So at the end of the day, as much as you enforce all of your controls and you put so many mitigations, you will only be as good as the people administering those controls and as the users utilizing those data and resources. So all companies now are spreading the awareness to their employees, whether they are IT or non-IT employees. At the end of the day, they're all using the network, they're all using applications and services provided and secured by those networks. So any abuse or the deficiency in the knowledge in an individual can cause a breach in an organization. Now we move on to some of the technical controls, and this is the area where most of the investment goes in when it comes to mitigations. So we already talked about some network controls that we have, which is the firewall. Now, the firewalls have evolved from stateless firewalls, which are called layer 4 firewalls, which are firewalls only protecting up to the TCP or UDP ports. So they don't have a state of the connection. So they only check the source and destination IPs and the TCP or UDP source and destination ports. And based on that, they will either allow or deny. We have the stateful firewalls, which will keep a session table. So it knows that someone from the inside zone, from the trusted zone, requested to go to a certain website. That certain website is going to send some traffic back, which is the website traffic. The firewall will have that knowledge that there was a session before from user X with IP X. And if it found that session, then it will forward the request coming from the entity. So it will have some sort of history. After that, we have something called the next generation firewall. Now, the next generation firewall is a firewall that goes up to layer 7, which is the application layer. So it actually inspects the packets or the traffic up to the application. But I just want to point one thing here. Now, a next generation firewall can always be marketed as a firewall that can inspect the application. However, it can only inspect what it can see. And the majority of data now is being encrypted from the endpoint itself. For example, like HTTPS. So the firewall, the next generation firewall, cannot inspect the data of the application if the data is encrypted. So in many cases, to have an efficient next generation firewall that's actually doing its job to the full potential, you need to have a decryption on the firewall to be for the applications to be inspected, and then you would re-encrypt that data going to its destination. Yes, it adds an overhead on the firewall in terms of resources and even configuration across the network. However, this is the optimum, let's say, next generation firewall. And then we have the IPS, the intrusion prevention system. Now, IPS systems are mostly signature based. So they are systems that have a database of signatures. So they try to match all the traffic that is coming through it. It's usually inline, so all the traffic passes through the IPS, and it gets inspected against a signature database. If it finds that a certain pattern of bits matches that one of those signatures, it will drop that packet. And now, in many cases, the firewalls are integrated with a built-in IPS functionality. All right, aside from protecting the network, we also have protections in the endpoints, which the majority of time, many exploitations are on the endpoints themselves, because this is where the users actually interact with the network. They are interacting from an endpoint, from their laptop, from their phone. This is where they open malicious files, they go to malicious URLs. This is where the majority of the attack vectors happen. So having controls in that area is very, very essential. Back in the days, it used to be sufficient to have an antivirus, which is a signature-based detection. So it will inspect any file against, again, a database of signatures. If that file is part of that signature database, it will quarantine or delete the file. However, even this kind of protection is now not sufficient. So we have EDR solutions, which is endpoint detection and response. And this has the intelligence not only to detect based on signature, but on behavior as well. So if there's a behavior of, for example, a PowerShell script running and then followed by certain activities in an operating system, then the EDR will intelligently detect this behavior as a malicious behavior, and it will respond to it based on its configuration, whether it will report it or it will actually block that behavior. And we also have email. Now, in most of the endpoints, like the workstations, we have email clients. And this is where we get so many of the phishing emails with malicious or malware attachments. So it's very important to secure the emails using an email solution. And that usually doesn't really gets installed on the endpoints. It's usually a solution that's on the network, but it will protect all the emails that are coming to the organization. The DLP is not something to enforce, or it's not a reactive control. It's data leakage prevention, which means that if I have a document, for example, I need to classify that document, whether it's a confidential document, it's a public document, whether this document is restricted to certain, let's say, departments in the organization. That helps to identify where to apply security the most. So if the DLP solution is enforced on the endpoints and in multiple places in the network, and we know that most of our confidential information, for example, is hosted on a number of servers, then we make sure that those servers are protected the most. And we make sure that, come to the next point, that those data is backed up, and this is very important. So in case there is a breach, you will always have a copy of your data to restore from. And the backups are as good as the backup retention policy that you have. So, and again, this depends on the organization requirements. For example, you can back up your servers every hour, meaning if after half an hour from the backup, you get a failure on that server, you will be losing half an hour of data from that server. However, that might not necessarily be a bad thing. Maybe it's something that can be tolerated by the organization. So it all depends on the application and the tolerance of loss for the application. Some applications can tolerate the loss for 1 week. So you will schedule your backups every week. And then we have encryption of data. So usually encryption is tackling both the data that is traversing the network. So we talked about if you're sending, for example, a file through the network, you need to encrypt that file so that when it crosses the network or traverses the network, it is encrypted. There is another form of encryption which is called encryption at rest, which is about encrypting data which are sitting, for example, on a hard drive. So that if there is a breach to a server that is hosting such data, they will not be able to view the data or access the data because it will be encrypted, and the encryption keys will be ideally sitting somewhere else in another server. Moving forward to identity and access management. In identity and access management, here we're tackling the AAA concept, which is the authentication, authorization, and accountability. So in most of our systems or applications, we always require some sort of authentication to verify the identity of the person trying to access an application, or the person, for example, trying to log into a network device to operate it. So some form of authentication will be there, whether it's password-based, certificate-based. You could have multi-factor authentication, just like we have now using our SMS or a soft token, like Google Authenticator or Microsoft Authenticator and so on. The authorization part tackles the level of authorization that you have on an application, for example, or an operating system. So if I'm accessing a Windows machine using the administrator account, the authorization I have will be the max. So I will be the admin on that OS. However, usually, if you are in an enterprise, your workstation will be limited as a user authorization role, which doesn't entitle you, for example, to install executables. So this is to limit the functionality for the user and only have admin access with the help desk, for example. And the third part, which is not actually mentioned here, which is the accountability, it simply means that if I'm accessing a device at a certain point in time, that there will be a log registered somewhere on a device that says that my user has accessed system, for example, server X, at this time. So this will also help during audit trails and if you're analyzing an incident. We have monitoring and detection, or what we call it as a SIM solution. It's a security information and event management solution. Now, if you configure all of those or implement all of those technical controls, you harden your network and you enforce EDR and email security on the endpoints, and you encrypt your data and everything. And if there is a breach to one of those nodes, how will you know as an organization? There might be a breach that you are not aware of, or there might be a log that is sent from, for example, a firewall indicating that a file was downloaded by a user, but nobody looked at it. In that case, the effectiveness of all of these controls will be for nothing. So without proper monitoring and detection of security incidents or alerts per se, it will be useless to have these controls. So this is becoming very, very important to have a SIM solution as part of an organization. The SIM solution is basically a collector that will collect the logs from all of these devices, whether it's applications, operating systems, network devices, endpoints. It will collect the logs in some form, usually syslog, and after it parses those logs, it will be able to detect security incidents based on use cases or alerts that we configure. Some alerts can predefine, for example, if the SIM solution gets a log file from a Windows server that user X has tried to access 10 times with a failed credential, then this SIM solution can be configured to send an alert to what we call a SOC operation center, or security operation center, which we call the SOC. And the SOC team members will then be able to take action or respond to that incident or alert and figure out whether it's a legitimate user that's trying to access with their own password, or whether it was a brute force attempt using their account. So the SIM solution is very important because it will have a holistic view on the security controls on your devices, so that you can have the assurance that whenever there is a breach or there is an abnormal behavior, your use cases in the SIM solution will help you to detect that. So use case enhancement and tweaking is very important as well. So you will always fine-tune those use cases such that you'll be able to detect the most sophisticated attacks. And moving on to the physical controls. So aside from all the technical controls and the administrative controls, we also need to make sure that our physical systems, like the servers, the workstations, are also secured. And we can do this in multiple ways. We can, of course, install cameras or CCTV systems to monitor our data centers, our servers. And we can have some kind of an access management to authenticate the identity of the person, for example, entering a server room or a data center through some sort of authentication, like a password, an ID card, a token, some biometrics, and so on. So this was just an overview on the current approach that's being taken by organizations and enterprises when trying to secure or enforce the cybersecurity in their organizations. So let's now move to some of the security risks, or we can call them some of the attacks or threats, and some of the controls that will help to mitigate those attacks or risks. All right, so the first one is a denial of service attack. Now, the denial of service, you might have heard of it because of the majority of attacks that are happening are usually related to some sort of a denial of service. Now, what is a denial of service? Remember, we talked about the availability pillar of cybersecurity. The denial of service attack tries to exploit the availability of a system or of a service. So when the service goes down due to a security incident, it's called a denial of service. The denial of service can either degrade the performance. So if you are, for example, accessing a website, you will feel that the website is very slow, or the response comes after a huge time, that usually it doesn't take that much time, because of an attack that's happening on the server at that point in time. Or it could be a total disruption of the service. So if you're accessing the website, you will get an error code saying basically the server is not available. So that's in the worst case scenario. And these attacks are of two different types, the denial of service attacks. One attack uses volumes of traffic to take down a service or an application. What it means is a large number of what we call bots or machines, they send huge amounts of data across, for example, the internet to a single web server, trying to overwhelm the resources on that server in terms of network utilization, like the bandwidth, in terms of CPU and memory utilization as well. So they will bombard that server with requests coming from multiple machines, and that's called a DDoS attack. It's a distributed denial of service attack because it's distributed across multiple machines, trying to target one machine. Now, that volumetric attack can be mitigated with some controls. Usually, those controls have to do with a scrubbing center. So you would have a solution that will detect if there is a huge number of traffic that is coming to your resources in a short period of time that you specify. You will immediately drop those packets or traffic without processing them on the web server. And so you will not be affecting the service in that case. Now, I mentioned here a breach of SLA, mainly because a denial of service attack sometimes not only affects the organization, but even the SLAs or the service level agreements that this organization have with maybe other organizations or with customers. So if you are providing a service and you have a contract with a customer, that your data or your service will be available 99% of the time. And you get a denial of service attack on your service that you're providing. And your website, for example, goes down for a day. And that breaches the SLA or the contract that you have done with your customers. So this will have implications like financial or legal implications in some cases. So the protection against such attacks is very important. And there is actually another form of a denial of service, which is not volumetric. It can come from a single machine to, for example, a web server, but that attack will have some sort of a crafted packet that if the server is vulnerable to that packet, if it has a bug, let's say the server is buggy to this pattern of bits. If it receives this packet, it will, for example, crash or reload or freeze. There are multiple things that, for example, on a web server, if you send it a crafted packet on using certain, let's say, fields in the header, that will make it or render it basically unavailable. So that's another sort of attack that is usually mitigated by other means other than the volumetric attacks. And we will go over some of the controls for that. Okay. The first control that we have here for the DOS attack, again, has to do with the availability pillar, which is the high availability or the redundancy design of our systems. So what does it mean to have a redundant system? Basically, I have, for example, let's imagine that these are two servers. They are serving a website. Now, there are two designs here. If I have two or more nodes, I can have a cluster, and that cluster will either be an active standby mode or an active mode. The active mode simply means that all nodes or servers part of that cluster are serving the users or the traffic that's coming to them. So they are all active at the same time. And in case there is a failure, the failed node traffic will go and get distributed to the other node or nodes. In the active-passive design, we have one node acting as the primary active node, so it's the only node processing the traffic. However, there is a node sitting by idle or in standby, waiting in case there is a failure on the main node. Then the standby node will take over and start processing the website traffic in this example. So these are two of the designs that are usually used. And as I mentioned before, to have a proper redundancy design, it needs to be end-to-end. So it's not only enough to have, for example, a cluster of web servers to protect the web application. What if there was a failure on the firewall protecting the perimeter? What if there was a failure on the core switch? So having the redundancy across the network and even to the application itself. So having a cluster for the MSQL database, for example, the Oracle database. Having, for example, redundancy on the application itself, like the ERP systems. So redundancy goes end-to-end for it to be effective. And there is always an activity to find out single point of failures that are recommended so that you find which areas of your service are having that gap of a single point of failure, and then you will try to figure out a way to have some sort of high availability for that weakness. All right, this control, it's mainly a control for network devices to protect them against failures in, let's say, the in-band or the data plane from which those routers are processing traffic. For example, imagine that as a network administrator, the administrator accesses the router interface to manage it through the same interface that the router actually processes all the traffic for the other applications or the other company services. So If the main link for that router went into a failure state for whatever reason, whether it's hardware or software failure, then even the administrator of that router will not be able to access the device to troubleshoot, to correct the issue. So always as a best practice and as a security control, if that device is a security device, for example, like a firewall, it's always recommended to have something called an out-of-band management, which means basically that the management of those devices or network devices is connected through a separate network other than the main data plane network that is serving, for example, the users or the customers. So you have a separate network for management. And if there is a failure on the main, let's say, circuit or connectivity, you will still be able to manage all of your devices using the management connectivity. If you don't have such an out-of-band management, it will be very difficult to access the devices. So you will have to actually go physically to each and every device. And these devices might be scattered across different geographical areas. Another control for the denial of service, and this is usually done for a volumetric attack on the DOS solution that you have. This is usually what's being done. You have some session thresholds. So you set, for example, and you configure your DOS protection mechanism to, let's say, if you are receiving more than an X amount of connections from a single IP, you will drop the connections exceeding that X amount. And this protects you from the volumetric attack in the manner that if you receive, for example, if I set this to be 10,000, so if I receive more than 10,000 connections from a single IP, I will assume that this is a malicious behavior, and I will start dropping or discarding any traffic coming from that IP. So there will be no processing of that data from the backend servers. Or you could do it on the TCP layer. So the TCP, as we said before, it's a connection-oriented protocol. And how it works is, once you send the TCP send packet, the sender will wait for some time. It's called the TCP timeout period for the acknowledgement to come back. So during this time, what will happen? The sender will actually hold some resources for this TCP send packet or for this connection. So it will hold some memory space and CPU space for such connection. So what attackers usually use is they send huge amounts of TCP send packets, okay, and they don't send an acknowledgement back. So to mitigate this, you could configure, for example, if you are receiving more than 10,000 send packets in a specific period of time, start dropping after that. Similarly, you could do it also on an HTTP protocol. If you're getting multiple requests within a certain period of time, it means you're getting a denial of service on your web server, so you will start dropping the data after that amount that's configured. So this only tackles a volumetric denial of service attack. It does not really mitigate the other type of denial of service attack, which targets a vulnerability in the end system. That attack can be mitigated through patching, for example, a vulnerability on a system. It can be mitigated through a next generation firewall that is detecting on an application layer that there is a crafted packet with a signature in that firewall, so it's matching a malicious signature, or through an IPS as well. Okay. The second threat or attack we have two actually here, which is packet sniffing and session hijacking. And these two are two different attacks. Now, the first attack, or the packet sniffing, it's not really an attack on its own. So what it means is you are on network A and you are sending your traffic to network B. Someone in the middle of the network, whether wired or wirelessly in the middle, they are sniffing or capturing your data or your traffic across the network. Now, if they are capturing this traffic and this traffic is not encrypted, then definitely there will be an issue here. They will be able to disclose any information, whether it's confidential or not. So that's why we always ensure that when we're traversing public networks, internet or other networks that are not owned by us, we always use encryption in transit, so that all the traffic traversing the network is encrypted. If there is a sniffer in the middle, they will not be able to do anything with that data because they will not be able to see the data. It is scrambled and encrypted. And the second attack we have here is session hijacking. Now, the session hijacking is an attacker in the middle. It's a man in the middle that is impersonating an actual, for example, website or an actual service. So usually the victim tries to go to a website. Usually the attacker will use another attack vector. In this case, for example, in this example, they might use a DNS poisoning. So if the victim wants to go, for example, to their bank website, the attacker will point them to the IP of the attacker website hosted on his machine. And the victim will then put their credentials to the attacker machine. The attacker will then open a connection to the actual website of the bank in this example, using the victim's credentials to access. So this is called a session hijacking attack. To mitigate such attacks, we said to use encryption. Now, encryption can be performed in multiple ways. You could have a virtual private network or a VPN. When it comes to VPNs, you have basically two types of VPNs. You have a site-to-site VPN and a client-to-site VPN. And it depends on the use case here. When do you use the site-to-site VPN and how is it configured? Now, the site-to-site VPN is usually between two networks, or think of it between a company having a headquarter, for example, in a city, and a branch network in another city. And they want to encrypt the channel in between or the path in between, which is usually over the internet. So they will form a VPN called the site-to-site, for example, from each of their perimeter firewalls to each other. Or in some cases, it could be from a firewall to a router or router to a router, as long as they can conform to a certain encryption protocol. Now, the most famous protocol used is IPsec for such purpose. So if both nodes in this diagram, you can see two firewalls are establishing a tunnel. If they conform to the IPsec tunnel configuration and all of them agree on the negotiation, they will form the tunnel and start encrypting all the data going back and forth between the networks. And you can do split tunneling where you only encrypt certain, for example, subnets traffic and pass the other subnets traffic as is, depending on the requirement. The second type of a VPN is a client-to-site VPN. Now, in this use case, I'm sure you're mostly familiar with this case because this is what we use, for example, on our phones or our laptops when we connect to a VPN provider. So in this diagram here, the user's laptop is having a VPN client as a software. Now, this VPN client will communicate to the VPN server, which is hosted, for example, in another country. And all the data going back and forth between the VPN client and the VPN server will be encrypted. So the internet service provider in the middle, or the ISP, will not be able to see the payload or the applications that you're trying to go to, or even the websites that you're trying to go to, because the whole application is being encrypted. And the only thing visible in the packet is the outer header, which is the destination IP address of the VPN server. So actually, all of your applications will be tunneled from the VPN client to the VPN server. So the ISP in the middle will see that you're going to the VPN server for all the traffic. And then from the VPN server will strip out the outer header, and it will be able to look at the actual destination that you wanted to go to. For example, you wanted to go to a certain website on the internet. The VPN server will then, on your behalf as a user, initiate that connection to the internet. So that website will actually see the VPN server as the source IP, not your user IP. And we usually do this when we want to appear, let's say, to the website as if we're coming from, for example, from a different country. And this is also used, the client-to-site VPN, for employees to access their company resources. So they would have a client sitting on their, for example, company laptops, connecting them through some sort of an SSL encrypted VPN to their main company HQ resource. We also talked about using secure protocols like HTTPS, for example, when you're trying to access any website, whether it's going to be having some sort of confidential data or not. Why is that? If you, for example, you're viewing a website that's not having any confidential data, or you're not entering any confidential data, why would you choose to go with HTTPS? It's for another reason, which is the authenticity of the website. What HTTPS entails is that you see the log sign here, it grants the website a validity of its certificate. So actually the owner of the website is validating its authenticity or identity with an entity called the certificate authority, which gives that website, let's say, a certificate saying that this website is legitimate and certified. And your browser, when it actually goes to any HTTPS website, it has a database of multiple verifiers that will verify the certificate validity and authenticity against multiple CAs or certificate authorities. So always make sure to use HTTPS when you are browsing, as it's encrypted and secure. Now, for administrators, when they're trying to access or manage their network devices, whether it's firewalls or routers or network devices in general, it's always recommended to use secure protocols like SSH, which will encrypt the data as it's being transmitted. The alternative here is the Telnet, which is a clear text protocol that is usually by default enabled on routers and switches, and it sends the credentials in clear text across the wire. So anyone sniffing the traffic can see your username and password. So enforcing controls like hardening systems when they first get connected to the network is important. So whenever you have a new router or a new switch installed, make sure that you go over best practice baselines to harden the system or the device such that you disable any unsecure protocols like Telnet, HTTP, FTP, and so on. Okay, the third control here for the packet sniffing and session hijacking has to do with wireless networks, because mainly packet sniffing is so simple to do over the Wi-Fi. Why? Because all the data is actually being transmitted over the air. No one is controlling that. You can just put a sniffer, which is just a simple antenna or an access point as a monitor, and it will sniff the traffic off the air and save it on a hard drive, for example. And from there, you can analyze the traffic and see what your attack vector is. I mean, if you are an attacker in that case. So securing the wireless networks is very important, because all your data over the Wi-Fi can be sniffed without your knowledge, because it does not require any physical input or any physical connectivity, aside from the physical, let's say, distance only. So they need to be close to your wireless endpoint. So in that case, we have multiple security protocols for the Wi-Fi data to be encrypted from your endpoint, whether it's a phone, a laptop, or some other Wi-Fi device, to the access point. or the router at our home, which is acting as an access point and the router. And one of these protocols is the WPA2, which is the most recent, the most secure protocol right now. And luckily enough, all the routers, the home routers now come with WPA2 as a default security protocol for encryption. And it's a pre-shared key protocol. So you set a password, and when you're trying to access the Wi-Fi, you just put in that password. Now, for organizations and enterprises, that might not be sufficient because you cannot have single password across your company for all the employees to access the Wi-Fi network. So what's done is having some other protocol, for example, a radius authentication protocol, to authenticate the endpoints to the access point. So the authentication request will go from the access point to a server called a radius server, which will authenticate the user based on the things that can be configured. For example, it can use passwords, it can use certificates, MAC addresses, two-factor authentication, and so on. So that gives it more leverage when it comes to securing endpoints or Wi-Fi endpoints in an organization. The last control here has to do with physical networks and wireless networks as well, which is enforcing endpoint security. Now, this only comes to picture when you are in an organization or a business entity, and usually the workstations or the access points, they will by default, a layer 2 switch, if you just connect a laptop to it, it will connect you to the VLAN that is configured on that port. And usually the layer 2 switches, you will configure all the ports to be data ports except the uplink to the router. So if any attacker or adversary connects their laptop to the switch, they will be able to, for example, get an IP or configure their own static IP if they know the subnet, and be able to attack from there. To control this kind of access on the layer 2, whether it's on the access point or on the switches, there is something called ANAC enforcement or network access control. This is where you authenticate the endpoints connecting to the network. For example, if you have your work laptop, most likely your work laptop, when it connects to the network through either the Wi-Fi or through the Ethernet cable, it will authenticate with the NAC server using multiple things. Again, it can use the MAC address of the laptop, which should be unique and for each laptop. It can also use the therefore only allowing the legitimate endpoints to connect to a network. Our final security risk here is malicious URLs and files. And we've already talked a bit about this. I will just shed some light into the importance of this, because again, as we said, this is usually something that end users will open. It's an end user that is opening a malicious URL. It's an end user that is downloading a file that they might think it's safe to download. So they will end up infecting their machines, and that's not the only risk to the organization. What if a machine is infected? That's not by itself an issue, unless there was confidential data on that machine. However, there are multiple things from that point. They can do a pivot attack. So they can, from that machine, try to exploit other machines on the network. They can exfiltrate the data to the outside. So they can actually start sending the data on that machine, for example, to a server on the internet so that they can have that data in their network. And that's a very risky thing for organizations, as I said, if there was confidential data on that machine. The controls, we have talked about some, for example, like the antivirus or the EDR. The proxy is simply a device that inspects web traffic. So to protect against opening or going to malicious URLs, the client will go to a website or the user will try to browse to a website, their web traffic or HTTP or HTTPS traffic will be sent to a proxy server, whether it's a transparent or non-transparent server, depending on the network configuration. It will be sent to that proxy server. That proxy server will then inspect the URL. If it's an HTTP packet, it will inspect the whole thing because it's unencrypted. It will inspect it. And if it's a proxy server that's actually doing decryption for HTTPS, it will also be able to check the content of the data and the domain that the user is going to. And based on multiple policies configured, like for example, the category of domain that the user is going to, for example, if it's political, it can be dropped on the proxy server. If it's a malicious domain, a well-known malicious domain, it can also be dropped on the proxy server. Otherwise, the proxy server will act on behalf of the client and open the session to the website intended on the internet, for example. Another control is email security. Email security is very important, as we said, because all the phishing emails will contain some sort of malicious payload, whether it's a URL or a file with some malware on it. Now, email security solutions will inspect files for against antivirus signatures and so on, but some sophisticated malware can even evade these controls. So some sort of sophisticated control is required. For example, like a sandboxing feature, which will emulate the execution of the file. So it will actually take the email content and the file on a server that will open the file. It will execute it on an operating system, and it will see the behavior of that file. If it finds it to be malicious and it is doing some of the things that it's not supposed to do, then it will block that email. Or if it sees that the file execution is not behaving abnormally, it will allow it. That's when it comes to protecting against malicious URLs. We also talked about the IPS, which is, again, it's either signature-based or anomaly-based. The anomaly-based detection is based on behavior as well, not only based on signature. And we also mentioned cybersecurity awareness multiple times because, as I said, most of the attack vectors come through the social or the human factor. And this is the weakest link in the chain, and we need to enforce the control there the most. I've mentioned here some of the additional critical controls that can be implemented, is not necessarily over the network. One of them is a continuous vulnerability assessment. So any organization is always encouraged to do periodical vulnerability assessments on all of their internal and external devices or services. The vulnerability assessment will disclose any gaps or observations on systems that needs to be remediated through patches, through reconfiguration, through any means to close such known vulnerabilities. This will harden the systems and patch them. The second thing is the incident detection and response. We also talked about this, which is having a SOC team analyzing incidents in real time using, for example, a SIM solution. And this is very important to have some kind of assurance and confidence in the security level of your organization. And the last thing here is the penetration testing. And this is something that can be also done on a periodical basis. For example, a company might choose to perform a penetration test on their external facing services to make sure that it is not exploitable and that they are hardened as well. And with that, I conclude the lecture part of today's session. I'll leave the floor now to you for any questions and answers.
Engineer Safwan, we have multiple questions, but can we go for the practical, if there's a chance?
طيب, sure. Right. Apologize due to the short time. I'll move on ahead which will not take long. I will just be demonstrating a few things for you to visualize, and then we'll give some time for questions.
Sure.
Okay. All right. So in here, I have a small lab setup. Basically, I'm having an HQ. Let's say this is a company and they have an HQ, a headquarter here, and they have a branch on the other side, and they are connected by the internet. So on the HQ, you have a perimeter firewall and a router to route traffic to the internet, and you have a server. On the branch, you also have the same perimeter firewall and router, and you have a client that will try to access something on the HQ. Now, for the simplicity of the lab, and just to give you an idea, I will only be using a ping as a test for reachability. I will be showing some of the baseline or enforcement controls that can be done on the network devices. And last, I will show an IPsec tunnel configuration and encryption, and validate that actually the traffic traversing the internet is getting encrypted or not. Okay.
Mohandas Safwan, we cannot hear you. Sorry, Yani. So check your mic, please.
Hello?
Yes, now clear.
Sorry, was it muted for long?
No. You can
Okay,
continue.
okay. Right. I was saying on the HQ firewall, I already made some configuration for the IPsec tunnel. Okay. And what I'll be doing the configuration on the branch firewall in order to establish an IPsec tunnel between these two firewalls, so that the traffic from the client to the server is encrypted. And to prove that, I will do a packet capture on this router and export that packet capture to my machine and view it on Wireshark to see the actual data. Okay, so now, before we do anything, I'll do a simple ping from the client to the server and start the packet capture on the router to show you the packets or the ICMP packets before the encryption. I already made some pre-configuration on the router to save time. All right. Of course, I can share all the steps with you later if you're interested to do a packet capture. This is a Cisco router. It's just a fast way for me to do the packet capture on the network in the middle, just to prove that encryption is working or not. Okay, so I've started the capture now on the router. As you can see here, the capture point is enabled. Now on the client, I'll just try to ping the other side. So this is the client. It has an IP of 10.2.2.2. The server has an IP of 10.1.1.2. So from the client, I'll just do a ping to the server. Okay. All right. So now this ping should have been captured on the router before we make any enforcement. Let me just stop the capture. And try to export it. So I'll be exporting the packet capture from the router to my machine to this directory. I already opened a TFTP server on my machine, which will accept this TFTP connection and save it on my machine for viewing. Okay, sorry, I think I forgot to disable my Windows firewall. All right, sorry for that. So I just disabled my Windows firewall, and now I tried to push the configuration again. Let me just, for demonstration purposes. Okay, so this is the file. You see, now this capture has multiple packets because I already configured one firewall with the IPsec tunnel. So it's actually trying to form the tunnel. So it's sending packets back and forth. And you can see these ESP packets are all the tunnel. And the ISAC AMP is also a protocol used for the IPsec tunnel configuration. But here is the ICMP or the ping that I did from 10.2.2.2 to 10.1.1.2. All right, so you can see here 1, 2, 3, 4, 5 requests. And these are the requests that I sent, the 5 requests that I sent from the client to the server. Now, this is something you can see in clear text now because it's not encrypted. Now, I'll do the configuration quickly on the firewall. I will not be explaining the steps due to the short time. Sorry for that. So I'll just create a zone and call it HQ IPsec zone. So any traffic coming over this tunnel will come on this zone. So if I'm gonna allow it on the policies, I need to mention this zone. Now all of these parameters I've already configured on the other sides and they need to match here. So this peer address is actually the address of the other firewall. Let me just show you. So interface 1, 2. So here, the firewall, I'm basically doing the IPsec tunnel from the firewall, the HQ firewall, Ethernet 1, 2, to the branch firewall on Ethernet 1, 2 as well. So any traffic going over this will be encrypted throughout the connectivity. So this is the interface 1, 2 on the HQ firewall. So I put it here as the peer address. Now, there is some sort of authentication here. You can choose whether it's a pre-shared key or password or certificate. I'll just put the same password I put on the other end. In here, what I'm choosing basically are the parameters of the algorithms used for encryption. So you always make sure that all the parameters are using the most secure algorithms. So for example, the DH group here is the Diffie-Hellman group. This is one of the algorithms for encryption. So I make sure I only use group 20, which is the most secure. Similarly, for authentication hashes, I use SHA-512 or 512. MD5 is insecure now. And for encryption, I'm using also AES-256. Okay. So this is the IPsec protocol, ESP, as I showed you earlier in the Wireshark capture. There is the authentication header protocol as well that can be used. So in here, I'll also pick for the second phase, Diffie-Hellman group, the encryption to be the most secure, the authentication as well. What I'm basically doing here, I'm establishing an IPsec tunnel using phase 1 and 2 with IKE version 2. Okay, so there will be 2 phases, phase 1 and 2. So this is for the IPsec tunnel configuration. Now, to route the traffic coming from this client to go to this tunnel, I need to add some routing configuration on the firewall so that anything distant for this server will actually be routed on the tunnel and not on the physical interface. So I'll just go to the virtual router here and I'll make the necessary configuration. So the subnet on the other end is 10.1.1/24. The interface, I wanted to go over the tunnel that I just created for the IPsec. And that's it for the routing. So by default, I have a static route here pointing to 10.20.22, which is the branch router. Now I'm on the branch firewall. So I push everything to the branch router on the physical link, except for I have a more specific route here. For this subnet specifically, I will route it through the IPsec tunnel. Now, on the HQ firewall, I think I removed the route as well. Let me just make sure it's there or not. Yeah, it's actually misconfigured intentionally here. So I'm pointing to 10.2.2, which is the branch subnet here. On the HQ firewall, I'm pointing to the physical link. I'll just move it to the tenant that I already created on this HQ file. So the similar exact configuration that I just did on the branch file. Let me just commit these changes. And let's hope that the IPsec tunnel comes up immediately.
I think مهندس صفوان ممكن ناخذ a couple of questions since the time is
Sure.
lost يعني. Sorry for the interruption,
Please.
we have to take some questions.
No, it's all right.
Okay.
Sure.
So Ghada is asking about how she can start اللي هو موضوع CTF اختبار CTF or competitions. I think she mean.
Catch the flag?
I think so.
Okay.
From where to start exactly?
Okay. Usually the catch the flag, it's not really a certification. You would be going to a penetration testing field here. So if you want to catch the flag, you need to be a pen tester. So I would advise you first, if I don't know what your experience is, if you don't have any experience in the cybersecurity field, you would start with CompTIA Security Plus. Security Plus is a comprehensive security course that gives you insight into many fields in cybersecurity, like encryption, disaster recovery, Wi-Fi security, and so on. Start with that, and then you can take some of the labs from Kali Linux or OSCP labs, and they are scattered online, and we can help you with that. I believe that is the best approach if you want to succeed in this path, so that you can participate in catch the flag activities. I'm not sure if that answers the question.
Sure. I hope it's clear. عندنا علي سأل عن الناك، يقول ما هو clear مرة، وكمان عنده سؤال على موضوع السيشن hijacking and the man in the middle. Are they the same or not?
Ali, I have a question. That's not okay.
Yeah.
All right, let me go over the NAC again. So the NAC is a security control to protect against devices that will connect to your access layer. So usually in a company, your workstations, for example, PC or laptop is connected through a wired connection to a switch. For example, a 24-port switch. Okay, this switch is then connected to the router and then to the rest of the network. So the first line of the network is the switch. Some attackers will actually try to go physically to the switch by going, for example, to the building where the company resides, and they will try to access, for example, the server room where the switch is. And if the server room is not secured with some physical security controls like an ID card access, for example, he will be able to access. Now, once he accesses that room, he can connect his laptop to the switch. Now, what is going to prevent him from accessing the network resources from the switch? Normally, the layer 2 switch doesn't have a built-in mechanism to block certain devices from others. Any device that connects to the layer 2 switch will be connected to the layer 2 domain, to the VLAN. And if the network is configured, for example, with a DHCP server, then he will be able to get an IP. So once he gets an IP, then he's on the network. So he can access the network as if he's a legitimate employee. So here comes the NAC. The NAC is a solution where when you connect anything on the layer 2 switch, before it gets connected to the switch and gets an IP or anything, the switch will send the authentication request to the NAC server. It's going to ask the NAC server to validate this laptop, for example. So it will tell it that I received a connectivity on port X from this laptop with this MAC address and this certificate. Now it's up to the NAC server how it's configured to tell. So if it has a list, for example, and that company, they have a list of all the MAC addresses of their laptops. It will check against this list, and if it doesn't find it in that list, it will not allow that laptop to connect to the network. Even though it's physically connected, but it will not be able to get an IP or anything. It will be isolated, so that port will be isolated. I hope that clears the question about the NAC.
Okay, so the other question is, let's pick up another or different persons. We have Fatima, she's asking about the spanning tree protocol. She wants to know more about the protocol, I think.
Sure. طبعا spanning tree, you could think of it as a security measure, or in most cases, it's an operational control that is configured to prevent layer 2 loops. So imagine if you have 3 switches connected to each other. So you have a triangle of switches. Now, in layer 2 domains, if you send a broadcast, this is how the network works on a layer 2. If you send a broadcast, the switch will receive the broadcast request, and it will flood it on all of its ports. So switch 1 will send the broadcast to switch 2. Switch 2 will then flood it to both switch 1 and 3. And 3 will do the same with 1 and 2. And they will keep doing this, and basically there will be a broadcast store, and there will be a loop which will exhaust the network resources, the links, the utilization, and even the CPU resources on the switches, because they will get so many packets looping around the layer 2 that they will not be able to process traffic anymore. So to prevent this, there is always a best practice design to have spanning tree configured. What spanning tree does is, let me just see if I can annotate here on the screen. Fadia, please tell me if it's going to show or not.
Yes, it's showing. Yeah.
Okay, so if this is, I just want to demonstrate real quick here. So if this is the connectivity, so these are 3 ugly switches, and if this is the case, there will be a loop if there is a broadcast, because each switch will send to the other switch any broadcast packet. The spanning tree, what it will do, it will actually be running on all of the switches. It's a protocol that will tell the other switches what ports it has and what data it's receiving from the other switches, so that the final design or the final operation state will be all links are active except one link will be operationally down. Okay, so the switches will agree on this without any manual intervention. They will shut down one port, or they will not send traffic to one port. So there will only be 2 links here, and there will not be a loop, because this link is no longer functioning because of the spanning tree protocol. So it's an automatic protocol to prevent broadcast storms. Just before we take any more questions, the IPsec tunnel is up.
Good.
I just want to show you real quick how can I remove this annotation. Clear. Okay, so you can see now the status of the tunnel. It's up. Okay, there are some packets. The phase 1 and 2 are both up. Okay.
I think just Turkey, if you have any questions, just type it in the chat and then we will answer it. بنرد على سؤالك بس اكتب بالchatting إذا عندك شيء.
All right. So on both firewalls, we can see that the tunnel is up, which means that there should be encryption based on our configuration. Now let's try this. Let's do the same thing on the router we did before. We'll enable the packet capture, which I configured on my own. I will just start the capture for the capture point I called CH. So now it's enabled. Let's just do a simple ping request from the client to the server. Again, we're doing a ping from the client to the server, which will traverse the firewalls. And we have configured the firewall so that from the private firewall, if the traffic is distant to 10.11/24, it will be encrypted, and vice versa on the HQ, if it's going to 10.22/24, it will be encrypted. Let's see if that's the case. So we started the capture. Let's do the ping. All right, the ping is done. We'll stop the capture and try to export it. This IP is my machine IP. I believe it was 164. Let me just, yeah, 164. I'll just name it encrypted. Okay. Yeah. All right, it's sent. So now it's here. This is the encrypted PCAP. All right, let's see. Actually, I'm seeing here the ping request. So the IPsec tunnel is not encrypting it. There must be something missing in the configuration that I missed. Let me just go back real quick. We can take another question while I check this.
Okay, so we have Samia is asking about what is the best certification that you recommend for beginner in the information security?
For beginners, the Security Plus. This is the first, let's say, cost-effective. You can take it as an exam or as a training with little cost. It will not cost you much compared to other vendors' training. And it will give you a comprehensive overview on the cybersecurity concepts. So it's a good one to start with. And then from that point, you can decide which path you're going to take, whether you're going to take a pen testing path, penetration testing, an analyst or SOC analyst path, digital forensics and incident response, or a network security and infrastructure security path.
I think also if they wish to build like a technical background, they will go for the CCNA, right?
For sure. I mean, before the security, I highly encourage that any individual to strengthen themselves in the network. So as you can see here, everything revolves around networks. We're talking IPs, ports, and this is just a firewall. Even if you go to the other security controls, to email, to other things, you will always talking about network terminologies. You will have network flows back and forth. So a strong understanding in networks will definitely help you in any of the fields in cybersecurity. Especially, for example, if you are a penetration tester, if you understand the network very well, you will be able to do a very thorough pen test by pivoting, understanding the subnets, the networks, the layer 2 vulnerabilities and layer 3 vulnerabilities and so on.
Okay, great. So let's have like, Muhammad is asking about what is the difference between the VPN and proxy?
Okay, the VPN is meant to encrypt traffic that will go, for example, to the internet. So by encrypting the traffic, you are hiding the content to anyone sniffing. Okay, so you are scrambling the data so that if someone in the middle captures the data, they will not be able to see it. On the other hand, the proxy is mainly to filter or inspect web traffic, not all traffic. So the proxy will filter based on URLs. We're talking websites here. So if you're going to a certain website, the proxy will inspect your HTTP or HTTPS request. If you're going to a malicious website, for example, it will drop that browsing session.
Okay, great. If you have, guys, if you have any other questions, you can type it because we will نختم
Okay,
I think.
Sure. Let me just point one thing. So the reason why that was showing in the capture is I did not clear the buffer before I made the other capture. So let me clear it real quick. I just want to prove to the audience the encryption and how effective it is in scrambling the data across the internet, and then we'll close. What do you think, Fadi?
Sure.
Fadi?
It's okay, but we have like less than 3 minutes.
Sure. It shouldn't take that much long. Okay. Let's hope now that we can validate the point. So, as you can see, this is the capture after implementing the IPsec tunnel. You see there is no ICMP requests, even though I just did a ping to the from the client to the server. Yet you don't see any application here except for ESP packets and some other protocols related to the IPsec tunnel. So this is what you would see if you encrypt your data over the internet. The attacker that's sniffing will not be able to see anything except encrypted packets. So the data is basically garbage data here. I hope that proves the point. Now we can conclude. I thank you very much for all the attendees, for the viewers. يعطيكم العافية. I hope يعني the intended benefit was met. And I'm sorry the lab was not very interactive. This was supposed to be an in-person lab. However, due to the situation, it had to be online. But inshallah, we'll have maybe other sessions where we get to do the lab for each and every individual attending.
Yes, thank you so much, Safwan. يعطيك العافية. يعطيكم العافية جميعا. I hope that it will be valued information. We have a survey بينرسل على إيميلاتكم إن شاء الله. نتمنى إنه تعطونا الفيدباك. And we will إن شاء الله stay tuned. There is many more coming lectures إن شاء الله. Thank you so much, Safwan. يعطيك ألف عافية.
يا هلا حياكم الله. السلام.
على خير. أهلا وسهلا.